Alright, so I think this is recording. Let's take a look at problem number 8, which it might be getting close to the last one. It wants us to find the intercepts. So let's find the y-intercept by letting x equal 0. If we plug in 0 into the function, in the numerator I have just a negative 16, in the denominator I have a negative 10. So those negatives cancel. Those are both even numbers. 2 divides both of them, so 8 over 5 is my y-intercept. For my x-intercepts, let's let y equal 0, which is the output of the function. So if a fraction reduces to 0, it'll be because of the numerator. However, we want to be careful and not say that a hole in the graph is an x-intercept, so we have to be concerned about division by 0. Well, I don't know what happened there. Alright. So x to the 4th minus 16, that's a difference of perfect squares. I have x squared plus 4 and x squared minus 4. But x squared minus 4, that factor, x squared plus 4 doesn't factor, but x squared minus 4, it's a difference of squares. So that factors to x plus 2 and x minus 2. In the denominator, we've got x minus 5 and x plus 2. So we know that this common factor of x plus 2 is going to create a hole in the graph that I don't want to call x equals negative 2 an x-intercept. So when I set this numerator equal to 0, after I've reduced it, I have two factors. One of these factors will never be 0. X squared is never going to be negative 2. Take any real number and multiply it by itself, and it's always going to be 0 or positive. How could it be negative 4 to cancel with the positive 4? It can't. So x equals 2 is the only x-intercept. So we had one y-intercept and one x-intercept. Alright. Let's keep my factored work here as alright. It's the end behavior. Let's come in and compare the degree of the numerator against the degree of the denominator. The degree of the numerator is 4. The degree of the denominator is 2. It's top heavy. There is no horizontal asymptote. So to determine the end behavior, we need to figure out as x approaches negative infinity. That's a sad looking negative infinity. Sorry about that. And as x approaches positive infinity, what are the y values doing? What's the output of the function doing? Well, we can determine that by plugging in extreme values into this function. And if we plug in extremely negative values in the numerator, x to the 4th dominates over this minus 16. That's not going to do anything. And in the denominator, these other terms, as you're far away from the origin, x squared dominates over those other terms. So in the numerator, we have some negative number, be it's raised to an even power. In the denominator, we have some negative base that's being raised to an even power. That's a positive divided by a positive. That ratio is positive. So this is going to positive infinity. So let's figure out as x is becoming positive what's going on. As you move, as x is very, very far away from the origin in a positive sense, to the right, very far to the right of the origin, we've got a positive number raised to the 4th power, a positive number that's being squared. So a positive divided by a positive, hey, that ratio is positive. So there's our end behavior. Alright, so then they want us to look at and see if the graph has any vertical asymptotes, and look and see if it has any holes, and to write the equation of the vertical asymptote and to identify the location of the holes. So if we recall my factoring, if it does, oops, that was, I wonder if I recall it. Well, yeah, there it is, hey. So vertical asymptotes, we focus our attention on the denominator after we've reduced the fraction. X minus 5 is the only factor left in the denominator after we've reduced it. So there's one vertical asymptote, and it's the line x equals 5. Because I set that equal to 0 and solve, right? Now, for wholes, you look and see what canceled, and you set it equal to 0 and solve. So x plus 2 equals 0. X is going to be negative 2. So there's one hole in the graph. We need to provide an x coordinate and a y coordinate. The x coordinate is going to be negative 2. If we plug in negative 2 in the original function, you get 0 divided by 0. That's not going to provide us a y. But in this reduced equation here, we have x squared plus 4 times x minus 2 and x minus 5. So what do we get if we plug in negative 2? Well, negative 2 squared is positive 4, and 4 plus 4 is 8. And negative 2 minus 2 is a negative 4. And negative 2 minus 5 is a negative 7. So the negatives are going to cancel, and if I haven't done any arithmetic errors, I'm getting 32 over 7 as the y coordinate for my hole here. I think that's correct, but I always make silly mistakes with arithmetic, so I hope that's alright. Hey, I hope that helps, and I will talk to you later.